Okay, so today we're going to explore a little bit deeper into our exponents from yesterday. We are going to be looking at 77 to start with. Let me move my screen around just a little bit here. Okay, so on this one right here, you'll notice that what we first need to do is we first need to figure out how to reduce, and this was very similar to yesterday, but we're seeing negative exponents now. So I'm going to talk a little bit about how we do this right here. Okay, so on this, what I'm first going to ask myself is what number can go both into 30 and into 18? What number can go into 30 and into 18? And I notice that 6 goes into both of those. 6 goes into both of those. So actually, I'm going to write down so that you can see kind of my thought process here. X squared, 18x squared over 30. And then I have x to the 5th, y to the -1. Okay, so on this one, I am going to first go, well, I know 6 goes into both of these. 6 goes into 18 3 times, and 6 goes into 30 5 times. Okay, so those reduce to 3 over 5. Now what I'm going to do is go for my x's. So I'm going to first do that. I'll put 3 over 5. Remember, when bases are alike, and you're dividing, you subtract your exponents. So we have x to the 2 minus 5. Okay, so 2 minus 5. And then I have my y to the -1. And I'll talk about that in a second when we simplify this one. I'll leave it there for now. We've never had this negative exponent, and that's what we're going to deal with today. But look at, not only do I have that's negative, but when I simplify this, 2 minus 5 is -3. So I actually end up here, my 5 has to stick, like those are staying the whole way because that's as simple as the numbers get. But I have this right here. We don't want to leave this as negative exponents. That's not something that we want to do. What we do instead is we actually move these down or up to change the exponent. Okay, and then I'll kind of go back in here and show you what I could have done right from the beginning so that way you can see that it's mathematically correct. And then I'll even plug in a number so that we can see that. Okay, so what this actually ends up becoming is the 3 over 5 doesn't change. That's never going to change. But this x to the negative power is going to move down and become x to the 3rd power. Okay, this y to the -1 power is going to move up, and it's going to become y to the 1 power. Or you can just put y. And that is my final answer. My final answer is 3y over 5x to the 3rd power. Okay, so I'm going to just single these out for just a minute to talk you through it so that you can see that negative exponent rule and how we can move it. When we had this right here, what I have is I have 2 x's on top. And on bottom, I have 5 of them. 1, 2, 3, 4, 5 of them, right? Well, what really happens is I'm crossing out 2 here, I'm crossing out 2 here, and I'm left with 3 x's on the bottom. I'm left with 3 x's on the bottom. So you'll see that that coincides with this right here, this idea of having x to the 3rd on the bottom. So my rule is holding sound right there. Okay, and I'll go ahead and generalize it like I did yesterday in just a minute. What I'm going to do first is I'm going to do B so that you guys can see another action example. So on this one, I have multiplication. So I have -5, then I have x to the -2 power times y. Then I have times -2, x to the 3rd power, y to the -2 power. Okay, so I'm going to start using my rules here. My rules say that these are every single thing that we have in here is multiplication, right? So everything is multiplication. So I'm going to first multiply my numbers. -5 times -2, so I'll start there. Okay, it's almost like combining like terms. It's that simplifying like terms. So -5 times -5 is negative, not a negative, it's going to be a +10, right? Negative times a negative is a positive 10. Then I have x to the, and remember, when bases are alike and I'm multiplying, I add my exponents. So I'm going to have x to the negative 2 plus 3. And then I have my y's. So I have just as plain old y here. That's like y to the 1 power. Okay, so I'm going to put that 1 because, again, when bases are alike and I'm multiplying, I add my exponents. So I'd have 1 minus 2 or plus a negative 2. You can think of it that way. 1 plus a negative 2, which would be 1 minus 2. Okay, I now need to simplify that. I end up with a 10, right? I don't need to put the positive. I have 10. And then I have x to the negative 2 plus 3 is 1 power. You don't have to have the 1, but I'm going to put it there for now. But then what I have is y to the 1 minus 2 power. 1 minus 2 is negative 1. We can never leave negatives. I don't leave negatives. Exponents. So what I have to do is I have to move this one down below, okay? I have to divide by it and change the sign. So my final answer is 10x, or 10x to the 1 power, you can put to the 1 power, that's fine, over y to the 1 power, okay? Which I don't have to do that either. But this moves down below and becomes a positive 1 now. Okay, we're going to do one more example that involves actually both multiplication and division. So it's a great example. And then you guys are going to kind of practice these rules on your own after I show you the generalizations. So I have this 15 over x squared times 1 over 45 x to the negative 3. Okay, so the first thing I want to do is I want to eliminate these parentheses and just have everything times each other. So that's what I'm going to do. I have a 15 times 1 on top, which is just 15. 15 times 1 on top. And now on bottom, I have an x squared times a 45 times an x to the negative 3. Okay, so what I'm going to do for this one, I'm going to do this a little bit different. I'm actually going to move this right away. I'm going to move this up, okay? I'm also at the same time, actually I'm not going to, I'm going to break it down. So I'm going to have 15 over, it's 15x to the 3rd power now. Remember, I can make it a positive, that's why I move it up, x to the 3rd power. And then I have over 45 and an x squared down here. Well, 15 goes into both of these, right? 15 goes into 15 one time. 15 goes into 45 3 times. So my number's reduced to 1 over 3. So I'll do that really quick. I have 1, and then I have x to the 3rd power over 3x to the 2nd power. If you really think of it, it means that I have 3 x's on top and 2 on bottom. Well, the 2 on bottom will cross out with 2, and I should get x to the 1 power up here. But we'll go ahead and use our rule, which says that when bases are alike and you're dividing, you subtract your exponent. So we have 3 minus 2. And then we have that over the number 3 down here. That number 3 doesn't change. Remember, these are here. I can put the 1 in front, but I don't have to. When you have a 1, it's just the same number. So I'm going to go ahead and start dropping that off. I have x to the 3 minus 2, which is going to be x to the 1 power over 3. And that's my final answer. I can leave this, or I don't have to. It's really just x over 3 that's my answer. X over 3, that is my answer. Okay, so now talking about the exponent rule for that one. You have all your different rules. We talked about all 4 of these yesterday. We talked about when bases are alike and you multiply, you add them. When bases are alike and you're dividing, you subtract your exponents. When you have power to a power, you multiply those. We even talked about any number to the 0 power is going to be equal to 1. Like that will always be the case. That doesn't work for when x equals 0, but I'm going to kind of shy away from that. And now we have our last rule, our last exponent rule, which says that when you have x to the negative 1 power, that's the same as 1 over x. 1 over x. Again, the reason it doesn't work for 0 is because when you have a 0 in here, when you have a 0, if I were to type in 1 divided by 0 in my calculator, when 0 is in the exponent, 1 divided by 0, it will always be an error. So that's why it doesn't work for 0. Okay, but that's our last rule right there. And the one that we're going to have problems with today. We're going to have these negative exponents that we have to move around. I do want to show you one more example, number 78. And the reason that I want to look at 78 is because you guys will see scientific notation, not only in my class, but when you get into physics, chemistry, a science class, you'll see this scientific notation, and I want you to start becoming familiar with it. When I have this 1.4 times 10 to the negative 1 power, it says that that is a size 7 shoe. A size 7 shoe is about that many meters long. So we're talking about meters here, okay? The circumference of the earth is 1.06 times 10 to the 7th power, okay, meters in circumference. So how many shoes end to end would it take to wrap around the equator, okay? That's really what our question is. Well, what I'm doing there is I'm actually going to be going through and dividing, right? I'm going to take my Earth's circumference divided by my 1.4 times 10 to the negative 1 power. It's that concept right there. Okay, so what I could do is I could do this. I'm going to go ahead and keep these the same because there's really no simplifying these two values, but I could take my 10 to the 7th power minus, okay, minus, remember you subtract them. Oh, but look at, it's minus a negative 1. Minus a negative 1, which is really going to end up being 1.06 times 10 to the 8th power over 1.4. Okay. Then you could actually go through and do that. What this is, 10 to the 8th power times 10 to the 8th power, it's really going to move this decimal place that's right here 8 places. 8 places. So there's going to be a lot of zeros here. But really, I just wanted to show you this. Let's go ahead and get the answer just so you guys can see it. So I have 1.06 times 10. Let me switch my phone. Raised to the 8th power. It's going to give you a really big number, right? And in fact, what you're seeing is right here, that decimal that was here moved back 1, 2, 3, 4, 5, 6, 7, 8 places. Just so you know how scientific notation works. In the negative 1, it would actually be moving it this way, the opposite way, 1 decimal place. Okay, so now we have this 106 million, right? And I'm going to divide it by my 1.4. It looks like we would fit about 75,714,286 shoes. Okay, that's how many shoes would fit around the equator, a size 7 shoe around the equator of the Earth. Okay. So go ahead and pop in and do some of your practice for tonight. You're going to be dealing again with this idea of a negative exponent.